Hey, I'm Mike Peel, and I'm here hosting the full crew for the first episode of the year. Today, we're going to be talking about robotics. Some of the topics we're going to be discussing are a resolution to the Ghost Robotics Boston Dynamics lawsuit, rise of automation and autonomy in construction, and an interesting drone development in the Ukraine that we're seeing. Drones running by fiber optic cable. And we've got some great guests to talk about these topics today. I'm going to start with Frasier. Frasier, tell us a little bit about yourself and what you do at KEF Robotics.
Sure. Thanks, Mike. So my name's Frasier. I'm the CEO of KEF Robotics, and we're a small business based in Pittsburgh, Pennsylvania. We're working on autonomy for aircraft. And specifically, we're trying to take cameras and develop navigation, hazard detection and avoidance, path planning capabilities to complete full missions for primarily DoD operators. So we're just approaching commercialization of our first products and working in a couple of countries, focused primarily on US and European defense markets at this time.
Well, happy to have you here. I've interacted with your team in my other work at the Drone Code Foundation, so excited to have you on and hear more about what you're doing a little bit later. So I got another, actually, I know everybody on this podcast today. We're going to go to Todd, who I've been working with since I was chair of Interdrone. So Todd is a great voice and always has been in the industry on the regulatory and IP side. So Todd, tell us a little bit more about yourself.
Thanks, Mike. Hey, I'm Todd Basile. I'm a partner at the law firm Greenberg, Traurig. We're a global law firm with about 2,800 attorneys. I lead our robotics and autonomous technologies industry group, and primarily handle tech transactions, which is any deal involving tech or data at its core, as well as patent law. I'm formerly a engineer at Bell Helicopter. I got my aerospace degree from Georgia Tech, and I'm also a Part 107 drone pilot. So definitely some deep roots in the industry and a nerd at my core.
Yeah, and I believe this is maybe the second or third time you've streamed with us. We've got another return guest, Sean, who I think you've been on 4. You might have the record now. So Sean, tell us a little bit about yourself, if for the audience that doesn't know you yet.
Yeah, glad to be here. Thanks, I appreciate it. I guess thinking about Saturday Night Live, I got to go for that fifth jacket, right? That's when you enter the 5-time club. But always happy to be here. Love sharing with your audience. I am the director of the Energy Drone Robotics Coalition. We have about 20,000 global members in the energy, utility, industrial space, and we work together to improve safety, efficiency, really drive ROI and data analytics for drones and robots being deployed in air, land, or sea.
Awesome. Great to have you back, Sean. We're going to start with our first article, which is, I believe, on Boston Dynamics finally resolving the patent lawsuit with Ghost Robotics. I remember this very distinctly because I was working with Rosscon or Open Robotics at the time, and they were a little perplexed. So, Todd, bring us up to speed what this was about and how it was resolved.
Sure. So this lawsuit's been going on since 2022. It's obvious. It has to do with these robotic dogs. Are we sharing the article on the screen? We are. Yeah. So most of y'all have seen Spot from Boston Dynamics walking around at the conferences. I know Sean. I see him at EDR every year, and so we're pretty familiar with those. Ghost Robotics is a company that came around in 2015 with their own offering as well. A little more military focused audience compared to Boston Dynamics, which is trying to be a little more commercial and industrial. But back in 2022, Boston Dynamics sued Ghost Robotics for patent infringement, initially on 7 patents that expanded to a total of 11. And it's been going on for quite some time, kind of a seminal patent infringement lawsuit in the industry. And they recently announced that they settled on undisclosed terms for the most part a couple weeks ago, I believe. So this article this entire case is, frankly, it just intrigued me from day one. I think it sheds light on a lot of things that are important for the industry, including the importance of having patents, including the importance of kind of doing your diligence before you hop in, as well as some policy sorts of things that we can dig into as well. But you know, that's sort of the 30,000 foot view of the case, Mike. And you know, happy to kind of drill down where we think the audience here might find interesting.
Well, I kind of have a follow-up before we give it to the other guests. So since it was settled, we're not going to know which of the patents actually were really violated or had any real potential to be violated. Because from what I know, some of the design stuff was open source way before Boston even implemented it. So is that the case?
Yeah, no, you're right. You're right. So there were no rulings made in the case as far as whether Ghost Robotics infringed or not. You know, these patents were around largely around control systems, right? Okay. Sensing and control platforms. There was one that has to do with a special architecture for an actuator. But as we often see in the robotics space, they were around control systems. So if you imagine, you know, one of these robotic dogs falls over, how do you make the thing know that it fell over and figure out how to stand back up, right? That was one thing. How do you help it climb stairs efficiently? How do you react to a situation where the gait of the robot is disturbed? So say uneven terrain, you're taking a step forward and all of a sudden like the ground is higher than it thought it was, and it drags its toe or something like that and gets tripped. So, you know, these patents were largely around those sensing and control platforms. And, you know, the case, they got deep into discovery, lots of depositions, lots of documents being exchanged, lots of sensitive information. And, you know, it got to the point where they had what's called a Markman hearing or a claim construction hearing, which, you know, if you think about a patent, right, you're trying to define a property boundary with words, right? This isn't like real property, dirt property, where you can, you know, easily have fence lines and monuments and landmarks and things like that. Articulating a technologically complex concept is difficult with words. And so you often have to sit there and say, well, what does that word mean? What does that phrase mean? And it's not always look at a dictionary. You know, you have to compare it to the context of how the patent was written up and stuff. And so this is always a very key part of every patent infringement lawsuit. You often see a lot of lawsuits settle after Markman because if it falls one way, one party wins. If it falls the other way, the other party wins. And here they did have Markman last fall. And unsurprisingly, as many of these go, we see a settlement afterwards. And you know, we can try to speculate and read in those tea leaves a little bit. Happy to, but you know, that's sort of the lay of the land and how we got here.
So, Sean, since you're familiar with these things, having run conferences and them walking all over them, what's your take on the lawsuit? And did you think there was a lot of merit to it, or did you have any interest?
Yeah, so thanks for asking. And basically, yeah, we have a pack of quads roaming around at our annual summit in June, no doubt about it. And so as far as the merit, I can't really speak to that one way or the other. I just don't have the knowledge base. But as far as my question, kind of back to Todd about this, is it seems like the resolution, at least always cast in the light of a press release, was very positive for both groups. So it seemed like the resolution actually was good for both to obviously get it settled and move on. What I was curious about is, as I mentioned, we work with a lot of folks around the world who are developing quad robots. And so I'm curious, is this the first, or is there going to be others you think that are going to come about? Because they do have many similarities, as you mentioned, to how they react to certain situations, as well as significant differences. So I was kind of curious your thoughts as to, is this the beginning, the end, when it comes to just quad robotics in particular?
Yeah, no, that's a great question, Sean. And honestly, I haven't looked into the full extent of, say, Boston Dynamics' patent portfolio, whether they have anything in terms of foreign patents, because you can only sue on patents in the country where the infringement's happening. You know, making, using, selling, all that fun stuff, right? Now, interestingly, I think last summer, Ghost Robotics was at 60%. Of it was acquired by a South Korean company. They acquired a 60% stake in it, and so I'm curious to see if there's any patents going on in Korea and whatever markets that Korean company is playing in. But that's of course just from the Boston Dynamics standpoint. There's other players, as you mentioned. I wouldn't be surprised if we see more, right? Because I think the viability of these quads is being demonstrated. I think that they have uses both commercially and in the military, which means demand. And whenever there's, you know, a sandbox that that's worthwhile playing in, you're going to see some of these sorts of things happening. So I wouldn't be surprised if it keeps going. And you know, to touch on your comment about it seeming to have been resolved positively, again, this is all, press releases are very sanitized, right? And I have no inside knowledge. I have no viewpoint on whether Ghost Robotics infringed or not, but my guess is there's a little more to it than that. I mentioned, hey, they had the Markman in the fall, and then shortly after that, Boston Dynamics filed what's called a motion for summary judgment, which is basically saying, hey, court, let's rule on this piece of the puzzle here, right now. The facts are undisputed. We don't need a jury involved. At this point, it's very clear Ghost Robotics infringes. This is, of course, what BD would allege. And so, you know, when you see that, you don't really get many bites at the apple for a motion for summary judgment. So when you see that after a Markman, you have to kind of think that the plaintiff there thought they had a very strong hand with respect to the couple patents that they did the MSJ on. And so, you know, if you want to read those tea leaves, and again, it could be plenty of other things. This might have been a situation where Ghost, you know, ended up having to pay some money or cross-license some technology or do something else that might have been a little bit painful to get to this point. But again, I don't have any insights. I'm just trying to read from what's publicly out there, which is actually fairly limited.
Well, Todd, isn't it the case sometimes when the two companies pat each other on the back in the final press release, it's because some licensing thing happened? Like, it's more likely than if they were walking away where one party was saying we weren't happy, but we had to settle.
Yeah. I mean, that can certainly be the case. They are talking about collaborating on some policy initiatives.
Right.
Right.
That's so like future work together.
You know, if there's going to be some ongoing collaboration, you generally want to frame things positively, and that very well could have been a very positive resolution as well, as Sean mentioned. But you know, I think on that might be a good segue to the policy piece of this. They were pretty tight-lipped on what those initiatives were going to be. They said that executives are going to meet here in early 2025, talk about things they can do to basically promote what's good for the goose is good for the gander for the robotics market. But you know, there was some things about, hey, are we going to militarize, you know, robots? That was kind of at the core of this. They have two very differing perspectives on that. But the thing that stood out to me was collaboration on supply chain initiatives. So very hot in the robotics, AI, drone space right now is essentially efforts to, you know, de-China, de-Russia your supply chains, which is oftentimes very difficult because I think a lot of the components and a lot of the things are truly made in those areas, and the United States hasn't become very competitive on a lot of that stuff. So I do think it will be interesting to see how they collaborate on that. The industry as a whole, all three of those industries, frankly, this is very, very sensitive, very important stuff. And so to see two leaders like this working together, even within their own niche here, I think you know, there's definitely some potential for positive outcome there.
So Frasier, you're on the opposite side of Pennsylvania as Ghost. I don't know if you knew they were also a hometown team. So what are your thoughts on ghosts? I mean, they are specifically targeting military. I know the campus that they operate on has incurred some protests as a result of that. And we know that Boston Dynamics made statements against weaponization. So maybe you have some insight into, you know, how that plays for both companies, what their perspectives are.
Yeah, I mean, I've been interested to watch Boston Dynamics as a market leader for 20 years now and do the truly amazing stuff with quadrupeds and humanoid robots. I've been a bit confused about how they plan to make money and whether they have a viable business model or whether they're going to continue to kind of innovate and be a lab. I think they've been procured or owned by Google and maybe like Hyundai, or maybe over the years they've kind of had all these deep pocketed kind of researchy objectives. And I haven't seen their dog as much as I've seen the Spot operate in the field, and pretty intrigued by what they could bring to the battlefield, which is where I'm kind of focused my thinking these days. But yeah, I have some insider knowledge on Boston Dynamics from people who have worked there and know their software and just sort of like how they're developing that. That's sort of intriguing to me. And I was, when I was reading this article, I caught up I got hung up on the quote from their legal team, Ghost Robotics legal team, that had a little bit of a snippy response to, rather than compete on a level playing field, the company chose to file an obstructive and baseless lawsuit. So the CEOs are playing nice. The lawyers have a few gripes, it looks like. But I don't know. I think I'd have to say I'm a little bit more impressed with Ghost progress of late than I am with Boston Dynamics.
Yeah, I mean, Boston Dynamics does absolutely amazing things. But I think you're right in that the tenor lately is, are you just going to make YouTube videos? So I would expect rather soon, though, they would start some form of commercialization, because I don't know how you can sustain being a lab. I mean, they're not like purely for research companies. So I would expect some type of actual productization soon. I don't know. Yeah.
I mean, I think about that. Not to get too far off the topic, Todd, here, because don't want to get away from your legal matters and those interesting things. But you're looking at, I mean, Tesla's producing a humanoid robot, and they're trying to come to market quickly. So Boston Dynamics, what's your response? Do you race to market? Do you find applications for your tech, or what are you protecting here? I think it kind of has me leaning into Ghost side of the story a little bit more, like, hey, let's just move fast and forget about these like crossover areas that we're both working on.
Yeah, I think, I can't speak to Boston Dynamics' commercialization plans or what have you here, but when you do characterize a company as sort of a lab for these things too, as an IP lawyer, right? I'm thinking, hey, look, they're developing a lot of great tech. They're patenting some of it. They're building up the source code to actually implement a lot of it. And, what you may or may not see, who knows? But from a company who does those sorts of things, it might be a licensing play. Right. So it's sort of like a university. Yeah. They'll do the research in-house and then they'll start licensing it out. I don't know if BD will ever go that direction or not. I think what they're doing there probably helps them build some of the other things that they're doing. And with Hyundai involved, car automation, like all of this stuff sort of goes together. And so, I'd be interested to see if they go that direction. This whole thing, what really caught my eye on this lawsuit right away was, and this comes from kind of from my nerdy side, right? Like, this is biologically inspired engineering, right? If you think about how is a dog going to get up off of its side, you're going to actually look at that, then you're going to mimic that with your sensing and control systems. How does it know what it's doing, where its legs are, this sort of stuff, and then how do you actually go and implement that information to help it stand up again and such? And so, I think they've got the humanoid robot, you've got the dog robots. When it's biologically inspired like this, I think it's just really intriguing, really neat, and there's a lot of lessons that can be learned just by having basic knowledge of biomechanics, and then that can, you know, benefit the other platforms and be licensed out as well. I mean, I got into the whole biologically inspired engineering by building a patent portfolio for a large university for their soft exosuit technology. And I can't tell you how many times I was walking around my office trying to, you know, flexion, this and that, like trying to mimic the movements and then create the control systems out of that patents. So I think I kind of digressed a little bit from that, but you know, we may, I think there's value in what they're doing one way or another, whether it's direct commercialization or some sort of other intellectual property play.
Definitely an uphill battle, though, right? When you compare what their competition is and where they're located in the world, right? So this was against a U.S. company, but you were talking about Chinese companies or, you know, other APAC countries that developed robots like this. Do they care? You know, so does the licensing play work as well there, especially when the innovation is mimicable because is already mimicking life, right?
Yeah. I mean, foreign patents cost a lot of money, so you really pick and choose where you're gonna file them and get them. Then you got to look at, you know, hey, how enforceable are they going to be in those jurisdictions? How favorable are they going to be to a U.S. company? And then, of course, the do you care part. And of course, things mimicable as well. I think, you know, in the robotics space, you can look at this and say, hey, look, I can mimic what a dog does. I'll build that up. But actually having the number of reps that Boston Dynamics does, repetitions, uses in the field, collecting all that data, building these giant data sets that really make it flow seamlessly and stuff, that can be quite the barrier to entry. And when that's in place, you know, some folks might want to cut the line and instead license some of that expertise and technology and then build on that. So, you know, even if it's not patent focused, I think there's a lot of value there.
Yeah, algorithms are definitely a good play for licensing. All right, we're going to move on to the second article, which is also about innovative uses of technology. So this is Frasier's article on drones guided by cables in the battlefield in Ukraine. And I have to say, the Ukraine theater has created a lot of innovations that like actually surprised me, right? Where being in tech for so long, you could kind of see what the next logical thing is, but this seems like a really interesting and innovative use. So Frasier, tell us a little bit about it.
Yeah, so this is an area I'm very interested in, and I kind of when we were doing some intros on the show, we talked about autonomy as a topic and slide and scale between automation and autonomy. And I'm really intrigued by this because this is not autonomy. This is actually kind of pulling back from autonomy towards human guided flight, but on a tethered fiber optic cable. And when I first heard this idea in the kind of like, actually, this is an older idea. It's probably 40 years old, but it hadn't before this war, to my knowledge, been done on the battlefield with small aircraft, like small, 2 to 3 pound sorts of aircraft. And so this has been an interesting thing to watch as the cat and mouse game on the battlefield has played out, where these new aircraft, which were really being leveraged in the earlier days of the war, very susceptible to electronic jamming and communication denial. And so a response is to, instead of communicating over the air, is to just use this fiber optic cable, and it spools out. It's a one-time use sort of product. So these are going to be left all over the battlefield. I don't think that's a huge environmental concern of any kind or whatnot, but it's sort of the detritus of war. And then the fact that they're really, really effective, and they're hard to come up with countermeasures against. And just from KEF's point of view, I mean, we're trying to do things where we're trying to put more compute on an aircraft and hand off tasks to the software on the aircraft to get around the jamming and the communication denial. But this, I kind of look at this with a little bit of envy and respect, because it's low cost, it's available now, and the product cycle has gone crazy, where you can now get these kits out of China for a couple of $100, which is frankly cheaper than the kind of capabilities that a company like KEF could provide. So I'm just very interested in the kind of as we incorporate robots into something as vital as war and defense and offense on the battlefield, that how humans solve these problems and what tools they use and what they kind of hack together and then commercialize and professionalize. And yeah, it's a little bit of a scary topic, but or just something you have to look right in the face and kind of think about and think about how we protect ourselves from this sort of world.
Well, defense use often leads to innovations that can be used later in times when we're not in conflict, right? So I'm already, the gears are spinning in my head here. Is this just for communication to the drone, or can it also transfer power? And if that case, is this like this is giving you an opportunity to run much larger compute on the device? I know we've seen tether drones in the commercial space before, but this seems like it's a different type of tether altogether.
Yeah. Okay. The tether's a great analogy, but there's no power going through this fiber optic cable. It's just data being transferred from the drone. Well, actually both ways, but you get in full motion video, very high quality, high bandwidth video off the aircraft to the pilot generally. So somebody's still on an RC controller flying these, just with a cable rather than radio. And then the operator can obviously send inputs to the drone so they can fly it remotely as well, even if the RC was jammed. So this isn't kind of a classic tethered drone where you're using ground power to stay aloft for a longer flight. This is additional mass that's cutting your flight time by some amount, but you have a more capable drone, and so they're making that trade of capability versus mission effectiveness and whatnot. And good point, Mike, on the innovation on the battlefield and where this might go into everyday life. Yeah, my first thought would be kind of underground robotics, where you need comms and you're going to lose GPS, and you don't want your operator to go underground, but you want a robot to explore. Certainly the quick and easy and reliable, it turns out, way to communicate with your extended drone operations.
So Todd, is this patentable?
Maybe. Everything is in some respect, but I mean, it's intriguing, Frasier. I'm curious. I don't know much about these drones, but did you read anything about sort of range limitations that might be involved here, either because you can't manage a cable beyond a certain distance, or because the mass of that cable becomes so heavy that a small drone really can't carry it anymore, or as you said, eats too much into its power?
Yeah, so it's funny because this product is it's now kind of like matured enough that when you go on a website, you can say, I want a 10-kilometer cable, or I want a 5-kilometer cable.
Wow.
So it's those are the kind of distances. And the way I think about it, it's one-time use. So it's just fishing line, basically. It's probably as strong and as thin as fishing line, and it's spooling out as you go. And it's not going to be at risk of getting snagged on something because you're just dropping it behind you. And yeah, you'd literally, as you're designing your aircraft and addressing your mission operations concepts, you'll be like, okay, well, for this type of aircraft, we'll need 10 kilometers. And so it's pretty wild, because it was, to my mind, brand new at this scale at the beginning of the war, and it's already matured.
Yeah, I can't say enough. I was actually surprised by this use case, because it seems like it might be convoluted, but then when you read into it, you're like, this makes sense for the task. It probably does have some restrictions for certain environments, like densely thicketed woods would be probably hard to navigate unless you know your trajectory already. But still really innovative use case. Sean, the energy sector is no stranger to hostile environments, right? So do you see a possibility for this being transferred to the commercial side, or do you think it's more of a long shot?
No, I think it definitely is. I mean, as y'all have both mentioned earlier, I think there's a lot of tech and innovation that happens in, both in a battlefield situation that's active, like over in Ukraine, or just coming from the Department of Defense. I mean, but their grants and the amount of research they do really does bring forth a lot of technology that's very applicable to any rough environment. So I would definitely say we've seen multiple types of robotics and control systems and things along those lines, BVLOS, that have been applied or have been developed for the defense. We're seeing a lot right now around middle mile drone delivery, autonomous cargo that is corresponding between the Department of Defense, and those companies are simultaneously developing for the commercial market. And I agree with what Frasier said. Anything when you think about mining, I'm thinking about nuclear, anything that's GPS denied, closed, like in a boiler, et cetera, which is throughout the energy complex. I could see where there would be possibilities that this technology might occur. The other thing that made me think about was we've heard a lot about, drones in the Ukraine on both sides. And it's amazing in a tough environment like that, very challenging, how they stress test the technology, right? So as you mentioned, Frasier, they developed this because it works. It gets around the jamming. It's simple, and it makes it happen. And vice versa, you see drones that are doing fairly well in proof of concept or field trials in other environments that suddenly fail when they're put out in mass like that in a really hostile environment that's very dangerous. So it works both ways. It proves simple technology that might be crossover to commercial, Mike, and at the same time, I think it also shows weaknesses for other technologies that were more encouraging in a different environment. So kind of back and forth, but it's always amazing the tech and innovation coming off a battlefield into the commercial sector. I think it's very viable and very likely.
I want to jump on that a little bit, because I think one of the interesting things about the Ukraine theater is perceptions of how comms and communication with the drones and these devices would work, and that just completely fell apart in the modern context of war. So you went from these giant drones to basically a $200 to $1,000 drone being the best drone for the job in a lot of cases. So just to fling it back to Frasier, what do you think have been the most kind of innovative developments that were kind of unexpected because of that?
Yeah, I mean, we're focused on the aircraft market, but there's been wild things happening with the ground robotics as well, where you've seen entire missions. And here's another fascinating part of Ukraine. We have video cameras all over the battlefield. Both sides do, and so you're able to watch footage coming off the battlefield of all these operations and see what fails in real time. Like, does this tracked robot get stuck in a ditch and become a useless, sort of object? So seeing the use of ground robots has been a little bit it's just been wild. And we talked to a lot of DoD stakeholders, and it is a mad scramble in the DoD to learn lessons coming off the battlefield, operational tactics and all that. It just seems like somebody used a great term recently. They said this is World War I tactics fought with World War III technology, and it's
insane how it brought it back to the trenches. But also you have the same thing where you feel safe in the trench, but there's a drone that comes in and bombs you. So like you have to completely redefine how you fight.
Yeah. So I mean, I hope the conflict resolves as tomorrow, but
Right.
from a preparing for the future sort of standpoint, just got to learn as much as you can from what's going on over there.
Yeah, for the Ukrainian sake, I hope it resolves in their favor as much as possible, as soon as possible. All right, so we're gonna come back to the home front for a little bit more lighter stuff to end the show. Always like to end the show on a light note. So we're gonna just quickly thank our sponsors: Anello, GNext, Carasoft, and Volatus Aerospace. A lot of them have been supporting us for a long time. We got some new ones in there, so we're really excited to have you on board. It's really great to have sponsors support the show in the way that they do and make this all possible. Also, thank you to the audience today. We've got a big crowd. I haven't even checked the chat. I'm sorry. I've been so involved with the conversation. So we got a good morning from Mark. Kimberly is saying hi from Sweden. Hi, Kim. Oh, Dawn tapped in for a minute, check in on us, I guess. And Mark had a comment. TOW missiles use similar technology. Anybody know what that's in reference to?
I'm going to say it's to the fiber optic.
Fiber optic?
Yeah,
Okay.
yeah. Tow missiles sometimes are shot off like the top of a Humvee, or I think there was the Maverick a tow, or off of an Apache. Yeah, they use fiber optics to help the pilot or
I have
second
seen
guy
that.
in there, the weapons officer, navigate the missile to the target. Yeah.
All right, so we're going to be moving on to the field of construction now. So, Sean, why'd you pick this article, and what did you think was interesting about it?
Yeah, so basically for us, it's when we started with energy and the overall industrial space, we started to see more and more deployments as we follow them that were happening in the construction area adjacent to the industrial. So we see a lot of construction, obviously LNG, a lot of renewables and solar, wind, et cetera. So there was a lot of construction going on in the energy space, and we started to see that they were deploying drones and robots. We started studying it and found that there were a lot of similarities between the construction market and the energy market. Many of those being obviously both of them were former bastions of traditional methods, did not use drones and robotics for their projects. But they're both going through some pretty dramatic transformation. And that's really a combination, I think, of AI, robotics, and autonomy kind of coming together. And why would they do that, or what are the challenges? I mean, they have labor shortages. Both of them have considerable folks in the great crew change, and the projects are getting much more complex, and they have a demand for improved efficiency. Both are under a tremendous amount of fiduciary guidelines to bring in projects at the lowest possible costs, but make sure that it's quality as far as construction. So we saw a lot of the similarities, and so it was fascinating to start studying how many workflows were already being digitized and changed with robotics in the construction space, and some of the benefits they were getting from it, which obviously is that increased efficiency, the safety, which is a huge case across both of those industries as well, enhanced quality. They're looking for greater sustainability and cost savings. So we're seeing a lot across both of them, and the deployments were very interesting to look at how many different types they had, from easy crossovers like surveying and mapping, right? You already are using that in a ton of different sectors. Well, that was an immediate crossover, or keeping up with projects as far as looking at how they're moving forward, or the delivery of the supply chain. There's all sorts of use of there in drones and robotics that crossed over, but then it moved into demolition, renovation, 3D printing, and additive manufacturing. We just saw all kinds of use cases, all kinds of robots, lifting, painting. It was kind of incredible to see how many there were already being deployed.
Yeah, it's one of the things that I first noticed at Interdrome when we were having construction speakers was how technologies that are able to automate any part of the job site actually bring the A, E, and C, architecture, engineering, and construction, closer together. So like the architect used to be joked about as, oh, that's just an artist rendering. That'll mean nothing on the actual job site. But as the digital twin gets manufactured and changed in real time on the job site, now there's better and healthier communication between all three of those parties. Another thing I wanted actually to bring up, because I was thinking about it when I was reading this article, was what's happening in California with the wildfires. It's going to require a vast amount of construction, and it's going to put a lot of pressure to build fast. And the truth of the matter is we only have so many construction personnel that can do these jobs. So it's not even a limitation on the resources, which of course would have their own limitations and supply chain issues, but just not even having enough people to build the new houses, which actually increases the rents, the prices for properties. It has kind of these inverse effects of what you would intuit from the fact that the land is now damaged. So any thoughts on how that could be applied to disaster relief and things like that?
Well, absolutely. I mean, your initial is going to be, they're using, obviously, drones will be used. So the initial for the insurance companies, right, who are going to have to come through in order to quantify, what the damage is, and instead of having to send out those adjusters, right? So that's going to give them an ability to maybe move forward more aggressively. And there's a whole lot of commentary that probably could be made around insurance companies and the situation there, which is a much bigger thing to unpack. But right off the bat, after a natural disaster, you're going to be able to use drones immediately to help with that, where you don't have that staff. And then when you start to get into the demolition, I mean, there's robotics that are applied now to front end loaders, lifters, all kinds of things like that will help clear the space so that the new construction can start. And then you have a variety of different drones, once again, that can be done with surveying and monitoring as far as mapping. And then also as far as marking the actual foundation, can be done with robotics. And then they could actually use robotics depending on what they're trying to do for the construction, whether that's just lifting, et cetera. So I think it can fill in where you're going to have labor shortages. It could potentially reduce some of the costs so that it doesn't become as expensive to rebuild in what's a pretty expensive part of the world to build anything. It's a challenge. So I think there's multiple ways they could be applied that would help fill in gaps in the workforce and speed quality construction at the same time. I think they could be applied from the very beginning of the process all the way through the final.
Frasier, any thoughts or questions for Sean about the article?
No, the article made me think about, I was talking to this, like a president of a company that developed wood products quite a few years ago now, like probably 8 to 10 years ago now. And he was talking about the viability of wood products in a world where there's nobody to hammer a 2x4 together. And he was thinking about, how do we make wood products that can be assembled by machines more easily? And you're seeing all these shaped wood products and whatnot. And oh man, it's such a huge market, and such an important, housing is such an important problem to work on and solve with. And robotics are going to be inevitably needed there. And I just think about how big that equipment is, how skilled human operators are that use it, the insane variety of environments you encounter even on a managed construction site. And it is just a huge, crazy problem that is going to require a lot of innovation and a lot of like supply chain changes, training changes. It's a huge one. It's a huge topic.
You know what you say is interesting, because in a lot of ways we have the in-between step already. When you look at skyscrapers, right, you prep the building and the area so that you can modularly build upwards. And if we were able to develop those systems, I actually think construction will, once they start really, really sinking their teeth into robotics, they'll adapt rather fast. And we already have some cases where you see 3D printed housing, right? And that's done from start to finish, basically with no or moderate supervision by the humans, right? Making sure that the process is going as planned. But once it's started, the robot is doing the labor, right?
Yeah.
Yeah.
Especially the repetitive.
It seems inevitable that, yeah.
Yeah, if it's repetitive, it's actually better when a human doesn't do it, right? Because we get bored very fast.
Bored, tired, injured.
Bored.
Yeah, I mean, you look at some of these autonomous bricklaying robots, you're looking at 3,000 bricks per day. So does that necessarily make them quality stonemasons? No. Stonemasons are still needed for a lot of different projects and work. But when it comes to just quality laying of bricks, they've got that. It's very deployable. So they're able to do that much faster, and they can do it every day.
Yeah, I just want to go really quickly back to Frasier's comment about manufacturing wood so it could be constructed this way. I think about two places. One is IKEA, dowels, right? So there is already a lock and key system there. But you also look at traditional Asian architecture, and there's a lot of lock and key, no nail work, especially in damp environments. And those structures survive a long time. So that might be a route to automation there too. We invented the nail, and then we get rid of the nail, right? So right. Todd, any thoughts on the article?
No, I think Sean, you captured it wonderfully, and I was actually having a conversation with I'll call him sort of their big data guru at Suffolk Construction a few months ago, and they're doing some really neat things in the robotics space with their jobs, as well as to use the way overused term AI space, really big data. I think this podcast is about robotics, so let me tie it into robotics. I think one of the, obviously, as we've discussed, one of the big benefits is them actually doing something, labor, right? Then there's the surveying and mapping, kind of giving us an idea of what's going on right now, so that we can make good decisions. I think sort of a sometimes overlooked benefit of them is just the massive amounts of data that they can gather as they go out and do their job, whether that job is looking at things or doing things, and then leveraging that data to derive insights for future projects, right? So, you think in, I work with several infrastructure inspection robotics companies, and, one of their big offerings that they have is the ability to talk about predictive maintenance, right? And so they can see how things evolve over time because they've done enough reps, and they can figure out, hey, when am I going to need to replace this? When am I going to need to repair this? Blah, blah, blah. I think in the construction world, you can draw analogies from that as well. You can say, hey, look, here was the progress. And, if you're creating a digital twin at certain intervals, it's very helpful. Here was the progress of all these other jobs. Well, we know in job A, when we saw this particular thing, the whole schedule got thrown into disarray, right? Or, you can start identifying those points where trouble, at least there's a correlation between seeing something and a problem occurring, a cost overrun, a delay, or whatever. And, maybe then be able to take quick, efficient action to overcome that and stick to your schedule and such. So, I think this industry can benefit greatly from the robotics sensing platforms, and frankly for feeders for big data insights. So
yeah, there's kind of a couple of domains that are bringing around robotics being used in new environments. One being computer vision, one being the data collection and ability to collect that data intelligently through machine learning, and brand new sensors that are able to utilize all of these data points together to take action reactively or actively in the environment. And it definitely is an exciting time. I want to give Sean kind of licks to talk about what he thinks is exciting on the horizon in this field.
Yeah, so from our perspective, I think you guys definitely started down that path, which is it's all about the data. I mean, at the end of the day, these things are actually doing work, which is very important for all the reasons we discussed. But what they are is gathering that data. And when you look particularly for the areas that we cover in the industrial energy sectors, it's amazing the amount of subcontractors and workers that you have involved in these projects. And to your earlier point about how many times it's being made, different parts of the project are being done off site and then being shipped in, and the logistics of tracking all that. And so I think that's the amazing thing, is whether it's a quad, whether it's a tethered drone, whether it's a variety of different types of robots, they're able to, in essence, capture data instantaneously, put that to multiple stakeholders to actually make the project more efficient. So I think it's going to be exciting to see whether it's residential from coming back from a natural disaster, like unfortunately occurred recently in LA, or whether it's going to be how do we build out energy infrastructure faster and better. I think it's amazing what we're going to see these robots, and I'm excited to see what they do as we go forward.
Well, thank you, Sean, and thank you, Frasier and Todd, for participating today and lending your voices to these awesome topics. Want to thank the audience for jumping in today, and all the viewers out there. Thank you for making the show possible. Also, our sponsors, Volatus Aerospace, Carasoft, GNext, and Anello, for lending their support to the show. And Dawn's got Ned Tabbitt coming up tomorrow on Dawn of Autonomy, so be sure to check that out. Thank you, everybody. We are out here.